sample. Huge. It's a huge sample. That's why your Mo shrinks down to 0.72%. I said something about an hour ago you might not remember. You were still kind of waking up at that point. I apologize. I was yelling too early. You can make any result statistically significant if the Mo allows you to, which means the Mo is very small. How do you get a very small Mo?
Large.
Big sample. Big sample. You can always get a statistically significant result if you sample enough people, and often enough. This is the problem with the OSU grad student, right? Eventually, you can get the result you want if you just keep sampling. So here's the problem. Well, not the problem. Let's look at the differences first. P hat 1, 6.3%. P hat 2, 4.9%. That's just what we saw. Those are the 4.3s and the 6.3s they were talking about in the article. The difference between them is 2%. They never mentioned the 2% difference, did they? They never once mentioned the 2% difference in that article. How come?
Because it doesn't sound very eye-popping.
Taylor, say that again a little bit louder. Because it doesn't have the POW factor. Are you gonna stop using acetaminophen, or recommend to your patients stop using acetaminophen? There's only a 2% difference in the behavioral rates.
People will be like, I'll take my chances.
I'll take my chances because my back hurts. Because this damn kid's pulling me forward, my back is killing me, and I got a headache, and I want to sleep. 2%. 2% doesn't have the POW factor. But that literally is the difference. Is it statistically significant?
Yes, because the Mo is so small.
It is, isn't it? It is definitely statistically significant at the 95% confidence level. Look at that. 2% is the this minus this. When you put the margin on that, we say it's at least 1.3% more, maybe as much as 2.7% more. Both of those numbers are above what? 0. And since they're both above 0, that means there's no cloudiness statistically significantly. There is a difference, and it's positive, which means P1, not P hat 1, but P1, we believe P1 is bigger than P2. If I may go back to the PowerPoint for a moment, just to bring this slide back up again. Not that one. This one. This is what we're interested in. See, lack of hats? Lack of hats. That means population parameters, right? We are interested in the difference between the proportion of misbehaving with the acetaminophen users versus the proportion of misbehaving with the non-acetaminophen users. Both these numbers are positive in our example, yes? 1.28%, 7%. They're both above 0. That means I'm 95% confident this is above 0. And if I'm 95, a little bit of math, if I may, a little bit of math. If I'm 95% confident that P1 minus P2 is bigger than 0, by doing a little tiny bit of algebra, I'm also 95% confident that P1 is bigger than P2. If I just add P2 to both sides. Does that make, just add P2 to both sides? Hopefully that makes sense. Believable. Fair so far? Okay, good. So, I mean, I'm not doubting statistical significance because it's there. Denali's good, brow is furrowing, that makes me happy. We're going to get to it, I promise. Come back. So there is statistical significance. 2% with the margin of error, it's 1 point whatever it was. I forget what it is, and I'll go back and look. There it is. Take a little bit bigger. There, right in the middle there. Here. At least 1.28, maybe as high as 2.7. I didn't see either of those numbers show up in the article, though. We didn't see those, right? It never said that it's 1.2 to 2.7% higher. What did it say? Remember the 31 and the 46? Go ahead, look at the article again. You got it in front of you, right? You got it in front of you? What are those 46, 31s, and 20, whatever the hell they were? What are they referring to?
A percentage of kids that have behavioral problems because of these?
Partially.
Okay.
But it was a comparator. They were comparing the kids with acetaminophen. Acetaminophen. I can't even talk today. I need more coffee. They were comparing the kids' behavioral problems with acetaminophen to the control group. But how are they comparing them? Look at read one of the sentences out loud to me. Go ahead, Denal. Do you have one right there?
Women who took acetaminophen at 32 weeks of pregnancy were 29% more likely than women who did not.
More more likely. Keep reading. Read some more of those things. Keep going. 47% experience or whatever, behavioral difficulties. Keep going, keep going, keep going. Read some of those ones down lower. They get into even more, correct?
Yeah,
I thought.
down here.
Yes, that was just the reported use of acetaminophen. That's how we got the actual numbers from the study themselves. So, do you remember? I'm going to back up. Maybe I'm being confusing with my questioning, and I apologize. I'm going to back up. I'm going to back up to this slide here. This paragraph. 46% greater risk. Greater risk. Obviously, if you subtract the percentages, we didn't get 46%, we got 2%. So how did they get the 46% greater risk? They didn't subtract the risks, they divided them. They divided them. They took, if you will, a little bit of math, a little tiny bit of math, from the front board so that people on camera can see. What's 6.3% divided by 4.3%? Mathematically, what is that? 1 point what?
1.2857.
1.2857, which means 128% bigger. 128% bigger. See what I did there? I divided the percentages. Now, when you subtract them, you get a difference of 2. When you divide them, you get a multiplication factor of 128%. What I've done, that's what they're referring to here. Now, where did the 46% come from? Hold that thought. Hold that thought. We're getting to that. What I did was, I added 2 other little categories into this spreadsheet that you are going to see in your research lives. Let me zoom in on these so we can see them.